So the homework assignment is to evaluate how well this simple equation characterizes the shape of this plume. And what this says is that the width of the plume, measured like this, is equal to a constant times the square root of the distance from the source divided by the Peclet number. Now, this constant is needed because the width of the plume here depends on what contour you pick. So in this case, I picked the zero point 0.05 contour, but if you pick the 0.01, it'll be out here, and if you pick the 0.1, for example, it would be in further. Okay, so this is needed to do that scaling. And so the way that I did this is to I copied the plume like this from COMSOL, copied the results, and then I got the data by going at, let me see, basically measuring it by hand. And so I went 100 meters downstream like this. The source is at x equals 100, and so I went 100 meters downstream there 300, and I just used this little box to make things square. So there's the width, and then I went over here and shuffled it down like that, and there's the width. So it looked like about 180 meters. Okay, so that's the width for delta L equals 100. And this analysis was for a Peclet number of 1. Okay, so then I could go downstream another 100 meters here to right there to 400 meters and get the width and so on. So I did that for a Peclet number of 1, and then I repeated it. Here's a Peclet number of 2, and here's a Peclet number of 10. So this is pretty clearly a skinnier plume, and so I got a data set for each one of these 3 Peclet numbers. And so here's what I did when I plotted this up. Here's the distance, and here's the data that I got from the analysis. And what I wanted to do is evaluate this function. So I put in this function in each cell right there. This is, well, let's look at it in this cell. It's square root of d5, the distance, divided by that number, which is the Peclet number, and multiplies by C1. And so what I did with this first data set is I set it up, and there's C1, and I just simply adjusted C1 to fit the data. And so that gave me, this is the first data set that I did for Peclet number equal 1. And just fit it. You could use solver and fit it automatically, but I just adjusted C1 by hand to get a pretty good fit. And what you see here is that the points are the data, and the line is this function. And what you see is that it can fit pretty well, and maybe I would make C1 a little bit bigger so the line would come up a little bit further. It fits pretty well, but it's pretty clear that the line has a steeper slope than the points. So the line is, this function is saying that the width is flaring out a bit more than what we're getting from the theoretical analysis. So that would be part of the evaluation. And you can see for these other Peclet numbers, you have the same kind of thing. The line is got a bit steeper slope, so it's opening a bit more than the data. But what we can also then do, though, is compare these different values for the different Peclet numbers. So I just ran the simulation 3 times for different Peclet numbers, and I kept this C1 constant the same. It's got units of square root of meters, and when I did it, I used a 0.05 contour, and it works out that 15 square root of meters gives me a pretty decent fit. So I generated these data and I came up with the 15 square root of meters, and then I generated these other data sets and I just kept the same value for C1. Okay, so what you get is that here for Peclet 2 and Peclet 10, we have the same trend where the dashed line is a little bit underestimating here as you get close to the source, but we definitely get a big change when we change the Peclet number. The plume is getting a lot skinnier, and this simple function does really a pretty good job of characterizing that, how the width of the plume changes when we change the Peclet number. Okay, so that would really be what I could get out of this analysis. That the simple curve, the simple expression, it does a pretty good job of estimating the shape, but there are definitely some differences. But it does quite a good job of estimating how the shape changes when the Peclet number changes, at least within this range of Peclet number 1 to 10.